So chapter 1 is all about linear equations, linear inequalities, and their applications. So in section 1.1, we're going to get an introduction to linear equations in one variable. So first off, let's determine what an algebraic expression is. So algebraic expressions are made up of terms. A term is a constant or the product of a constant and more variables. Constant refers to the number part. So for example, here's our term 7. It is 100% constant, whereas 9a is made up of a constant, 9, and a variable a. Y is just a variable. It does have a constant coefficient. That leading number is 1. And I've got 5x squared, where 5 is my constant and x squared is my variable. The constant that multiplies the variable gets a special term. It's called the coefficient. So for example, I've made this little table here for us. If I just have a constant, the coefficient is 7. If I've got 9a, the coefficient is 9. If I've got y, the coefficient is 1. Well, remember that 1 times y is just going to be y. So we don't really have to write that coefficient in front. And then the coefficient of 5x squared is 5. An equation is a statement that two expressions are equal. So to solve an equation is to find all numbers, we call those our solutions, that make an equation a true statement. So here I have two expressions, x plus 2 and 9, and when I set them equal to each other, that gives us an equation. And my goal is to figure out, okay, what value of x would make this a true statement? Well, in this case, if x was 7, right? And I'm going to teach you guys a systematic way to solve all of these problems without just having to visualize it. A linear equation in one variable, here x, we're going to use x primarily as our variable, can be written in the form ax plus b equals c, where a, b, and c are real numbers and a doesn't equal 0. That's because if a was 0, it would just be two constants equal to each other. This is called a first degree equation because the greatest power on our variable is 1. Remember, x to the first is just x, right? Anything to the first power other than 0 is just, well, including 0, it's just itself. So I could have x plus 1 is -2, x minus 3 is -5, 2x plus 5 is 10, right? And we have our coefficients of 2, 1, and 1. So we have two properties we can use when solving linear equations in one variable. We've got an addition property and we've got a multiplication property. So let's say I have a, b, and c that are real numbers. Then the equations a equals b and a plus c equals b plus c are equivalent. So you can kind of think of this as a scale. We're trying to keep this level. So if I've got and if I add the same thing to both sides, my weight, my scale is going to stay level. We also have the multiplication property of equality. If I have a equals b and ac is b, then I multiply both sides by a constant, then ac and bc are equivalent. So these are our addition and multiplication properties of equality. So here are steps for solving a linear equation. So the first step is you need to simplify the algebraic expression on each side of the equation by combining like terms. So adding common variables, adding constants if you can. Next, you need to collect the variable terms on one side of the equal sign and all of the constant terms on the other. You then want to isolate the variable. That's typically going to be by dividing by the coefficient. So we're trying to find when x is 1. So we'd want to divide by when the coefficient on x is 1. So you're going to divide by the coefficient to get x all by itself. Lonely x's. That's one thing I used to say in my other classes, is we like to keep our x's lonely. Okay. Next, you're going to check your answer by plugging the solution back in the original equation. We're going to do this a couple times. I'm not going to do this every time. It's definitely something you should do on an exam if you have extra time, on a quiz, and things like that. So step 1, I want to simplify the algebraic expressions on each side by combining like terms. Well, I can't do that anymore. But I can move my variables all to one side. So if I've got an x on this side, to take it away and move it to the other side, I would subtract an x. And I've got a 2 on this side. I could subtract 2 from both sides. That would give me 4x equals negative 6 minus 2, which is negative 8. Now I need to isolate my variable by dividing both sides by my coefficient, which is 4. That gives me x is negative 2, and we can check our solution. Let's check our solution in orange. I have 5 times, we're going to substitute. We check our solution by substitution. I don't know why I crossed that D. Substitution. So I've got 5 times negative 2 plus 2 equals negative 2, which is my x, minus 6. So I have negative 10 plus 2 is negative 2 minus 6. I get negative 8 is negative 8. That checks out. We found our correct solution. Let's go ahead and solve another example. So we have to simplify each side of my algebraic expression. In this case, we're going to use the distributive property. We talked about that in section R.4. So I have to distribute this 3 and this negative 5. 3 times 3x is a 9x. 3 times negative 4 is negative 12. Negative 5 times x is a negative 5x. Negative 5 times 2 is negative 10. I'm going to go ahead and add 12 to both sides because that will make these 12s cancel out. I've got 9x minus 5x plus 2. I'm also going to go ahead and add 5x to both sides because that'll make this cancel out to 0. Again, we're collecting all of our terms on one side of the equal sign and the constant terms on the other. That gives me, 14x equals 2. So I get x equals 2/14, which is 1/7. That would be our answer. So let's work through a couple harder examples. The first one involves fractions. One thing I recommend doing as opposed to attempting to add these fractions would be to get rid of the denominators. I want to find the LCD of 2 and 6, which is going to be 6. So if I multiply both sides of my equation by 6, let me show you what happens. I get 6 times x plus 6 over 6 plus 6 times 2 minus x over 2 equals negative 24. My 6's cancel, so I just have x plus 7. And this 6 has a factor of 2 in it, so I get 3 times 2x minus 8 equals negative 24. I can then go ahead and distribute and combine like terms. I'm going to do so up here. So I have x plus 7 plus 6x, because I'm distributing this 3. I've got 3 times 2x, which is 6x. 3 times negative 8, which is a negative 24, equals negative 24. 8, 16, 24. Yeah, that's right. So I go ahead and combine like terms. I have 7x equals, plus, well, maybe not plus. Next I have 7, because I'm combining my terms, minus 24. That gives me a negative 17 equals negative 24. I add 17 to both sides. I get 7x equals negative 7. I isolate by dividing by the coefficient. I get x is negative 1. All right, for step 2, we're definitely going to have to use our gym skills, right? We definitely want to follow the order of operations. Let's switch to another color. How about green? So remember, we got to simplify our grouping symbols. Well, I can't do anything over here, but I can distribute. So I get 20 minus 6x plus 8x. I'm just going to go ahead and simplify this right-hand side. 20 minus 6x plus 8x is 20 plus 2x. So that right-hand side is fully simplified. Next, I'm going to have to simplify what's in here. So I've got 6 minus 1 plus 2x. So I distribute that negative. So I have 6 minus 1 minus 2x plus 10x. I combine like terms. I have 4 times 6 minus 1, which is 5, minus 2x plus 10x. And now I can distribute that 4. So I have 20 minus 8x plus 10x equals 20 plus 2x. I have 20 plus 2x equals 20 plus 2x. Oh, what's going to happen here? I'm going to subtract 20 from both sides. That gives me 2x equals 2x. So 0 equals 0. This is a true statement, but we never solved for x. Well, let's explore what that means.